In this video we will look at repairing the battery clips in an old Pantech meter. This is one of the first analog multimeters I ever owned. It's made by Carlo Gavazzi. It used two 1.5 volt AA batteries for the ohm circuit and a 22.5 volt battery for the protection circuit. So if we have a look at the back of the machine and we open the battery compartment, we can see the problem straight away. We can see that on the 25 volt battery, the positive terminal is broken. We can see corrosion on both negative terminals for the 1.5 volt cells. So these will have to be replaced or repaired in this case. So with the back cover off, we can get to see the corrosion and the damage in the battery terminals a little easier. So yeah, they will have to be cleaned or repaired. So now that we have the back cover off, we've got to remove the 4 screws that are holding the printed circuit board down. Excuse this because it's just very hard to do with just one hand. So once the 4 screws are removed, we could then slowly lift out the board. There's no clips that we have to worry about that will hold the board in place. Before we lift out the board, we have to disconnect the positive and negative wire to the meter. So now we can look at the PCB a bit better. When we look at the back of the board, we can see a lot of flux residue on the contacts. So when we remove the old damaged contacts, we're going to clean up the board at the same time. When we look at the front of the case, we can see it's pretty clean, so there's not much we need to worry about there. So now we can see the board and the contacts, the damaged contacts have been removed. The board has been cleaned with a bit of IPA. So if we look at the back of the board, we can see it also has been cleaned with some IPA. So it shouldn't make it easier for us to solder the new or repaired contacts back in again. I washed the rest of the board as well just to clean it up. As the negative terminal on the 22 volt battery compartment was actually working fine, I moved it into the positive position because I was going to replace all the negative terminals with actual springs. So here I can see the original clip, and I've actually soldered on some battery springs to each one of the clips. So these are going to be used for each of the negative terminals. So it's just a matter of deconstructing an existing AA battery pack, cutting out the springs and just soldering them directly to the spring metal that was left for the clips. We can now see the board assembled with the new clips that have been repaired. Next step is to attach the meter wires back to the board. So our next step is going to add the 4 screws that are going to hold the printed circuit board back into the front of the case. Now that that's done, I just want to check the controls to make sure that they're all free moving before I put the back of the case on. So we'll try out the rotary switch, we'll try out the slide adjuster for setting the DC, ohms or AC input. All looks good. add a couple of AA batteries in, so at least we'd be able to test the ohm circuit. I don't have a 22.5 volt battery, so I have to be very careful using the meter because there's no auto protection circuit now running. Okay, we have the meter assembled. It's in a stand and it's resting on the bench. Notice the pointer on the meter is not at 0. We want to adjust the 0 control on the meter itself to get the pointer to be resting at 0 when it's sitting in this position. So here we can see the needle is below 0. So I'm going to use a small screwdriver to adjust the 0 control, and it will push the needle up. Using the mirrored surface behind the meter and the needle, we want to try to get a solid red line that appears. We can see there the parallax is off, where the needle is just bang on 0. This is something you have to do with most analog meters anyway. That's close enough. So I'm going to connect a couple of probes. I have the meter set to 100 ohms and it's on the ohm scale. So when I short out the contacts, the needle will deflect to the far side of the display. So we can adjust the ohm control on the meter to get it so that the needle is actually showing 0 on the right hand side of the scale. A bit too far. So the control is a bit sensitive, which would indicate that I should have actually washed it with some switch cleaner or something like that. But it will, just for the purpose of testing, this will do. With the meter set to 5 volts DC, I'm just going to connect a battery to it and see will I get some form of a deflection on the meter. So yeah, there's something there. Yeah, about 1.3 volts. Well, I think that's enough testing for the moment. I'll come back to this in a later video. Thanks for watching. Bye.